Good morning, everyone. Today I'm going to explain about fuzzy clustering, specifically fuzzy C-means, which is an advanced extension of K-means clustering. The main idea behind this concept is to handle the situations where data does not belong to strictly to one cluster, but instead as a partial belonging. This is very important in the real world data where boundaries are not what we are going to learn in this presentation. In this presentation, we will be moving step by step. First, we will understand the limitation of the traditional clustering methods like k-means. Then we will introduce to the fuzzy clustering and understand how it works. After that, we will going through the mathematical formulas in details. Then we will solve a numerical example step by step. So let us understand what is hard and soft clustering. Let's first understand the difference between the hard and soft clustering. In hard clustering, each data point belongs to exactly one cluster. For example, in k-means, once a point is assigned, it cannot be belong to another cluster. But in soft clustering, also called as fuzzy clustering, each points can belong to multiple clusterings with different membership values. This membership values ranges between 0 and 1. This makes fuzzy clustering more flexible and realistic. Let us take a quick recap on k-mean clustering. K-mean is a simple and widely used clustering algorithm. It works by dividing the data in k clusters. The centers of each cluster is calculated using the means of the points. Let us understand the formula of the k-mean cluster. Mu k equals 1 by nk multiplied by summation of xi. Here mu k is the centroid, nk is the number of points, xi are the data points. The goal is to minimize the distance between points and centroids. But the problem is that it forces a strict assignment. What is fuzzy C means? Fuzzy C means is an improved version of K means. Instead of assigning a point to one cluster, it assigns a degree of membership. For example, a point may belongs to 70% to a cluster A and 30% to cluster B. This approach is more natural because in real world data, usually the data will be overlap on each other. Next, the three main pillars of fuzzy mean clustering. Fuzzy means works on the basis of three important concepts. First, the membership function, which tells how strongly a point belongs to a cluster. Second, cluster centers, which are calculated using the weights average. Third, the fuzzy parameter M, which controls how soft an art cluster is. These three together define how the algorithm behaves. Membership formula. Now let us understand the most important formula. Mu ij equals 1 divided by summation over k of the ratio of distance raised to the power 2 divided by m minimize 1. Let us break down what it actually means. Uij is the membership of a point I in cluster J. Xi is the data point. Cj is the cluster center. The key idea is if a point is closer to a cluster, its membership value increases. If it is far, the membership decreases. So the formula compares the relationship between the distance. Next comes the fuzzy parameter. The parameter m controls how fuzzy clustering is. If m equals 1, it behaves like k means. If m is greater than 1, the clustering becomes softer. Typically, m is chosen as 2. If m increases, cluster overlap more. Cluster center formula. The cluster center is calculated using Cj equals summation of Uij raised to m multiplied by Xi divided by summation of Uij raised to m. This is a weight average. Points with higher membership collaborate more to the centers. This allows the cluster centers to adjust smoothly. Objective functions. The main goal of FCM is to minimize the objective function. J equals summation of Uij raised to m multiply by square root square distance between xi and cj. This ensures that the points closer to the cluster have higher influence. Algorithm. Let us understand the step-by-step algorithm. The algorithm follows an iteration process. Step 1. Initialize the membership value randomly. Step 2. Calculate the cluster centers. Step 3. Update the membership value. Step 4. Repeat until it converges. This loop continues until changes become very small. Now let us look a numerical example. We have a 4 data points in 2D space. We want to divide them into two clusterings. We also define an initial membership matrix. Each column sums to 1, satisfying the content. Step 1. Calculate the centers. We calculate this cluster centers using the formula. We substitute the membership values and data points. After calculating, C1 becomes approximately 2.34, C2 becomes approximately 4.15. These are the initial cluster centers. As you can see, here is the calculation of the whole clustering. So C1 is equals to 0.8 whole square into 1 plus 0.6 whole square into 2 plus 0.36, 0.3 whole square into 4 plus 0.2 into whole square into 5. So we will be calculating like this using the formula, which is a central formula, which is summation of j uij power m into xi divided by summation of I into uij power of m. So by calculating the what are the data points which are given here, UI1, I mean U1j, U2j. So we are going to take these points and we are substituting directly into the formula. After substituting, we are getting the two clusters as 2.34 and 4.15. Next, distance calculation. Now we'll calculate the distance between each data points and cluster centers. These distance are important because they determines the membership value. So here is the distance formula. So applying a membership formula is like Uij is equals to 1 by sigma k dij by dik or 2 by m minus 1. So we can calculate it. We know the distance formula like under root x2 minus x1 whole square plus y2 minus y1 whole square, or you can directly use the mod function. So here we are calculating distance of 1 1, distance of 1 2. From x2 3, we are doing distance of 2 1 2 3. For x3 2 1 2 3 1 3 2. So like that we are calculating the all distance and we are substituting those distance in this formula. Next, iteration process. We repeat this process of updating clusters and memberships, which each iteration values become more stable. Membership values move closer to each other, 0 or 1. Conversions. The algorithm stops when the difference between old and new membership values is very small. This means the clustering has stabilized. Clustering analysis. The objective function keeps decreasing with each iteration. This shows that the clustering is improving step by step. K-means versus FCM. K-means uses hard assignment. Fuzzy C means uses soft assignment. FCM handles overlapping data better but requires more computation. Applications. Fuzzy clustering is used in image segmentations, medical diagnosis, pattern recognition, market analysis. It is usually where uncertainty exists. So, conclusion. Uh, fuzzy means always fuzzy means allows partial membership. It improves the cluster analysis in real world data and it is more flexible than k-means. So as you can see the advantages and limitations over here. So thank you.